What this question comes down to is the relationship between the mean of three numbers and the median of three numbers. Now we know that the median of three numbers would just be the middle number. If you arrange them in ascending order, the middle one is the median. The mean is going to be that magical point from which the deviations above cancel out with the deviations below. And under what circumstances would the mean equal the median? That would happen if the set is symmetrical. So in the case of a set of three numbers, for it to be symmetrical, the lower number and the higher number would have to be equidistant from the middle number. And if that's the case, then the mean and the median would be equal to one another. Now, we're already told in the free info that the mean of the three numbers is 120,000. We're interested in the median. And statement 1 tells us that one of the three numbers was 110,000. So I have the 110,000. I know that the mean is 120,000, but there's still two missing numbers. What could those two missing numbers be if we know that 120,000 is that magical point from which the deviations below and above cancel out? Well, the other two numbers could be 125, 125. So each of them is 5 above, and we've got a 10 below, so that cancels out nicely. They could also be 120 and 130. So the 120 is not deviated from the mean at all, and we have 10 below from the 110 and 10 above from the 130 to cancel out. Now those would lead to different medians, right? If it's 110, 125, 125, the median would be 125. But if they're 110, 120, 130, then the median is 120. So statement 1 is not sufficient on its own, and we can go ahead and eliminate A, D. Now, it's very tempting to say that if statement 1 wasn't sufficient on its own, statement 2 wouldn't be sufficient on its own either, because they seem very similar. Each of the statements gives us one of the missing data points. But what's special about the second statement is it just so happens that that data point is the mean. And why is that significant? Because again, the mean is that magical point from which the deviations on either side cancel out. So if 120 is one of the data points, then the other two data points would have to be equidistant from 120. So they could be 60 and 180, or they could be 100 and 140, or they could be 110 and 130, or they could be 120 and 120. But in all of those scenarios, the middle of the three data points is always going to be 120, and that means that the median is 120. So statement 2 is sufficient on its own just because of that coincidence that one of the data points happens to also be the mean of a set of three numbers. That wouldn't work for larger sets because then just the number of possible scenarios is much greater. But if it's a set of only three numbers and one of those three numbers is the mean, then by definition it will also be the median of that set. So correct answer here is B. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.